2, simplify the following using the order of operations. So whether you use PEMDAS, GEMDAS, GEMS, PEM, whatever, they're all the same. Grouping parentheses, that would come first. So what's inside the parentheses, do that first. You could add those to get 8. And then any exponents, we can deal with that. So on your calculator, this button right here will square anything. We had 8 squared. Yeah, okay. So I could put in 8 and then square it, and then it'll give me what that is. Now for the 3, you can do a couple different things. You can either, it was 2, right? Yeah. So I can put in 2 squared and then go to the left and change it. Or I can put in 2 and use this little up arrow above the division sign. You get there either way. Cool. Alright, and then we did grouping or parentheses, exponents. That would also include like radicals, square roots, cube roots, stuff like that. And then the part that a lot of us in general get confused about is the PEMDAS part of it. I like to write it like this. To me, it doesn't matter if it's multiplication or division that comes first, and then addition or subtraction that comes first. It's just whichever one comes first as you read it left to right. So I am multiplying here, so I can go ahead and do that. And then you could put this all in your calculator at once. You could do it one by one. That is completely up to you. I'm just going to put each part in. So this would give me negative 40. And then if I combine these two, negative 40 plus 32, that would be negative 8. So all got negative 8. Good. Thank you. I did that. That's okay. This is a learning experience process, yes.
It says simplify how that didn't solve it.
So there's nothing to solve because we don't have an equal sign. So simplify means do whatever you can to get the most simplest answer. And in this case, I can do all of those. Now if there were equals, then I would just solve it. That's okay. Because we're going to be practicing all year long. Alright. Other questions on 2 before we do 4? I don't know if we'll have time to do 5 before lunch, but we'll try. Okay. Alright, number 4, so we're doing solving. Here we have something where we can distribute this negative 7. So we're going to multiply that to both numbers, bring everything else down. Be careful with your negatives, that's going to make 8 plus. Combine your like terms, do exactly what it says. Negative 4 plus 21, don't do the opposite. And then we would start to solve this like a regular problem. Get rid of 14 by subtracting. Something. My brain completely blanked on that. 60. Thank you. And then divide on both sides.
Oh, what's that supposed to do? Equals plus equals.
4. It was 3. I didn't actually. Questions on that one? So most issues with this one would be from not distributing to both things, forgetting to multiply the negatives to get positives, doing opposite things here when combining, putting in negatives when there should be, stuff like that. So be mindful of all of those things. Be checking your answer in Desmos algebraically by putting it back in. Okay, we can try this last one. Alright, and the last one, we're solving for x. We gotta get x by itself. What would be our first step? No. Don't cry. Someone says advance. Yes, we can get rid of 8. And then how would we get rid of the negative 4? Multiply by negative 4. Now, we could have multiplied at the beginning, and I'll show you that example when we get back. And that would have worked. We just would have had to do it to everything. Okay, so make sure these answers, work and answers, are on your answer sheet. You don't need to keep the small little sheet of paper unless you want it. But after we have done 5 of these, you will turn in that bigger sheet. So keep this one if you want to. But I'm not checking this half sheet, just the big sheet. So keep that in mind. Okay. You guys can grab your phone for that. Because I mentioned that you could have multiplied everything by negative 4 first. True. But because I'm choosing to do that, I can multiply every single thing. I can't just multiply this part. I'm going to multiply this by negative 4, this by negative 4, and this by negative 4. And I'm not breaking any math rules because I'm still multiplying to both sides. I just have to multiply to everything. So the 4 squared would still cancel, just leaving x. This would become negative, alright, length 32. No. What was that answer? Sorry. Yeah. Okay. Negative 32 equals negative 20. And I would add 32 on both sides. So you can still get the same answer. Just a different way. Okay. Questions on that? Look at your course calendar. Today we are starting a new unit. You can look and see what all topics we're covering, but most of the stuff should be familiar to you, but we are going to go through each of it, slope and writing equations and graphing and intercepts. Take note as to when the delta mass are due, which ones are formative, which ones are informative. Remember that you should be trying all of them, no matter whether if it's formative or informative, and then quiz and test toward the end of September. And then flexing. Questions on any of those things? Many of us are not doing the discussions. They are informative as well, but it does kind of help you understand it in a different sense. So maybe not the solving aspect of it that we're doing in class, but being able to describe certain things in different ways using words. So make sure you're doing those things. Alright, so we are going to start off with learning about slope. If you grabbed an iPad, I need to show you something on it later, but go ahead and close it right now. You don't need it. Alright, so in this link up top, when we talk about a rate of change, that's a ratio that shows how one variable changes with respect to another. You can summarize that, you can write all of that. That part is up to you. So you might see these words be interchanged, rate of change, or on a graph, we're talking about slope. Those are interchangeable. Slope is written as a ratio, so we're usually dividing some fraction, of the vertical change or the rise to the horizontal change or the run between any 2 points on a line. And this remains constant for any 2 points on the same line. That means between point A and point B, point B and C, C and D, and so on and so forth, the slope is always the same. And then to go back to the ratio, slope is written as a fraction in simplest form. And when we talk about slope, it's represented as the variable m. Once you have all of that written down, draw in these four axes in these words, sorry. So these four sets of graphs and these four words. Positive, negative, 0, undefined. And we're going to draw rough sketches of what these different slopes look like on these graphs. So don't feel like it needs to be perfect.
I'm not so this one.
Alright, so for our positive, it's going to be a line that looks like this. So when we talk about positive slopes, we need to think about the directions we could go to get a positive slope. So if I'm looking at this left to right, I always want to do rise up or down over run, left or right. So if I'm looking at this left to right, I'm going up and then to the right. And that's one way you could get a positive slope. But there's another way also. Let's say instead of looking left to right, I'm looking right to left. I could go down and to the left. In general, down and left are negative directions. So if I have a negative over a negative, it would become a positive. So either direction is fine. They will both give you a positive slope. So then for negative, it's opposite. So the opposite direction. Where if I'm looking left to right, I'm going down and to the right. Or if I'm looking right to left, I'm going up and to the left. So when you have a negative slope, only one of the directions should be negative. Because if both of them are negative, you're making it positive. 0 is some straight horizontal line. Because if I'm looking at the rise, am I going up or down? Well, my line is a little crooked, but pretend it's just really straight. Am I going up or down? No. So I have like some 0 over whatever my one is. And 0 divided by anything is what? 0. So the slope is always going to be 0 for that one. Undefined is going to be a straight vertical line. Whoa. There it is. And here, I am moving up and down, so I should probably have arrows on these lines. Okay. So I am moving up and down this line, but am I moving left or right? Because this one's just straight up and down, so I am moving up and down, but I'm not moving left or right. And in your calculator, I want you to pick a number, whatever number, your favorite number, sure, and then divide it by 0. So number divided by 0. What happens? I pick a number and I divide by 0.
It just does this.
Yes, it should. You cannot divide by 0. You get an error. So that helps us tell us that the slope is undefined because we're dividing by 0. Our run is 0. Okay, questions on that part? So we're going to use that to find our slope in the next 4 and then any on the back. Does anyone still need this before I switch to this? In this box over here, put rise over run. Just so we know we're always going to be moving up or down before we go left or right. Think about like when you get out of bed, most of the time you sit up before you get out, unless you roll out, then that's a different case. Okay, so we're going to look for points. The points are a little hard to see. Sometimes you won't be given points, sometimes you will. When you're given points, it's really nice to see, and we can figure that out. If you're not given points, you're looking for where the line crosses grid lines perfectly. So like in this case, those are really the only 2 points. But in the next one, we'll talk about some others. First, what type of slope is this going to be? Positive, negative, 0, positive. Good. Which means we're going to be going up and to the right, or down and to the left. I'm just going to redraw those. And we're just going to count. So from this point straight up, I'm going to visually show you how I'm counting, but you don't need to do this part unless it helps. So I'm going up 1, 2, 3, 4, 5, 6, 7. And then I'm going to the right. 1, 2, 3, 4. So that would be some fraction 7 over 4. That would be my slope. I'm going to show you how you could see it the other way, but do we have questions about how we found that first? No. If that were something we could simplify, we would do that. But can I simplify 7 over 4? No. Great. I said you can do it both ways. So you just have to do rise first, up or down first. So if I start at this point, I'm just going to count down, straight down first. 1, 2, 3, 4, 5, 6, 7. So I'd be going down 7. That would make it a negative 7. And then to the left 4. So that would make it negative 7 over negative 4, but the negatives will. That's why it ends up being the same thing. It does not matter which way you count, as long as you go up or down first. Questions about that? Make sure you're putting m equal so that we know we're talking about the slope here. Okay. And number 2, what type of slope is that?
Negative.
Negative. So somewhere we're going to have a negative in there. I see visual points. So I'm going to start from this one. And I'm going to count down. It goes down how far? 3, and to the right how far? 9. So because we went down, I'm going to put the negative with that 3. And then could this be simplified?
Yeah.
Yes. So you can either do that in your head, or you can use your calculator to put in the fraction, alpha y equals, and put that in and see what you get. What would that be if we simplified it?
1 over 3.
Negative 1 over
There
3.
it is.
So what that means is every time I go down 1 and to the right 3, there should be another point that falls on this line. So I'm going to check that. I'm going to start at the top, and I'm going to go down 1 and to the right 3, and there's another point that falls on the grid lines. And if I do it again, down 1 to the right 3, same thing. And if I could keep drawing, there would be multiple points everywhere. Now, I could have went the other way and went up 1, 3, or 9, it doesn't matter. I could go up 1 and to the left 3. And you would want to write it because the positive is, the up is positive and the left is negative, like this. But the negative can't be in the denominator, so we want to move that either to the numerator or out front. It will still give you the same slope. You would just rewrite it different. Questions on that part? Okay. We talked about this slope already, but before we get into that, I want you to write these letters. H-O-Y-B-U-X, Hoybux. So that stands for horizontal lines have zero slope and are y equals. And then the opposite, vertical lines have undefined slope and are x equals. Right, so this is a way to remember if maybe you're getting them confused. Think Hoybux in your mind anytime you need to talk about slope or these things. So this is a horizontal line. Anytime you see a horizontal line, no matter what, the slope is always going to be 0. Could we count it and do the same thing? Sure. I don't have a rise. It's not moving at all, up or down. I can count, let's say I'm counting to the right. But 0 divided by any number is still going to give me 0. So I don't need to do the counting part. It will always be 0. Same thing with the undefined. It's a vertical line, so the slope is always going to be undefined. But if I wanted to count it, I am moving, let's say down. But I'm not moving left or right. And because when I go to check that, I would get an error, it's always going to be undefined. Do you have any questions so far on how we find slope? I want you to look on the back of this. There are a bunch of graphing slope questions. Any of those you want to see, you go over and have questions about. Did we have any questions on that back page before we move on? So one of the delta math tests due on Friday is going to be talking about how to find slope from a graph, and it'll be 2 parts for the first. There's 2 delta maths. The first one is this, and the next thing we're going to talk about. So go on to the page that says slope formula. And write this. So the slope formula is used to find the slope between 2 points, x1, y1, x2, y2. So you need to know this formula. It's also posted right behind me. There's a vocab thing right from there, so if you ever need to refer back to it, it is over there. But I am going to mention a couple things. Let's say we forget the order, and we switch this. As long as we also switch the denominator, we're good. But if you only switch one, you're going to end up with a positive when it should have been negative, or vice versa. So just keep that in mind. And we need to simplify all this. So I'm a visual person, so I'm going to label these. The first one I'm going to label x1, y1. The second one I'm going to label x2, y2. And then we're going to put each of these numbers into this formula. So y2, so m equals y2, the 3. We are always subtracting no matter what. Our y1 is 1, all over our x2, 4, and our x1, minus 1. So we should always be setting up our slope to look something like this. And then we just subtract. So 3 minus 1 is 2, and 4 minus 1 is 3, and that is our slope. Questions about that? Yeah. If we could. Can I simplify this? Can we simplify it right now? No. But if we could, yes. Yes. Okay, let's try another one. Number 2. Again, I'm going to label. If you don't need to label, you don't have to. But if it helps, do that. We're going to do the same thing. M equals y2, negative 2, minus y1, 4, all over x2, 10, minus a negative 2. So write it like this first, and then once you get the hang of this, if you want to change it to a plus later, we can do that. You're always subtracting no matter what, even if what you have is negative. Negative 2 minus 4 is what? Negative 6. And then if you want to change this first, you can. 10 minus a negative is going to become a plus. And then 10 plus 2 would be 4. Can that be simplified?
Yeah.
Yes. So negative 1/2. Yes. Any questions so far? Okay. We're going to do one more. 7, 8, 9, and 10. Just X those out. I forgot to change those. You're not doing anything like that. Don't worry about those. Try them for challenge purpose only, but you won't see that anywhere else. You can cross those out. But we're going to try number 5. We're going to skip 3 and 4, 12, and 5. Before we start anything, what do you notice about these 2 points? They both have to say that again. 9. Okay, that's going to be important. So when we go to solve this or set this up, it's going to be 9 minus 9, y2 minus y1, over 3 minus 5. What's going to happen then? We're going to get a 0. And 0 divided by anything is 0. So if you get a problem where your y values are the same, that's going to be some horizontal line where your slope is 0. Now, I still want you to set this up and do the work algebraically, but keep that visual in your mind as well. So then something similar is going to happen in 6, because our x's are the same. What do we think that slope is going to be?
0. Oh, slope.
It is going to be a slope. We're just trying to figure out what. It is going to be undefined. So if we set that up, 5 minus 8 over negative 7 minus a negative 7. 5 minus 8 would be negative 3. What happens in the denominator? going to get an error at the end, yes, because this becomes
A zero.
a 0. Now, I didn't change it, but if you wanted to see that, it would be -7 plus 7, which is how we got it, which is why it would be in the column. Any questions on how we find slope using the formula? Everyone go. Okay. Looking at 3 or 4, or on the very last pages where there's other slope formula, are there any of those that we want to go over before I let you practice? 4. 4. So 4 on this page, right? Right. So let's set this up. M equals, what would I put first? What's RY2? 4. Minus, what's RY1? 0. Over -2 minus 10. Good. 4 minus 0 would give us 4. And -2 minus 10. -1. There we go. And then simplify. So we want to put this in as a fraction if you're using the calculator. That way you don't get a decimal. It is -1/3. Good. Any other questions? So you can check your graphs, you can check your slope by using the graphs on Desmos, but you still need to know how to do this algebraically. So I'm going to really quickly show you how to check yourself in Desmos. It would be like what we just did, the counting part, and then we're going to, everyone needs their iPad so I can show you how to access Canvas. I'm going to put in 2 random points, it does not matter what they are. Okay, so if you were to put in the points, you could manually count it. Now sometimes I am too close to the board and I miscount, so I like to go into this and I think it's this. No. I'll figure that part out. There's a way to add in the numbers that you want. Oh, I think it's also position. This way. There we go. Okay. So if you take off the minor grid lines, add in step 1 for both the X and Y, you can see this even if you zoom in, zoom out. That way the numbers disappearing doesn't confuse you if you need that. But then you would just count your slope. But that's a good way to double check yourself. Okay? If you didn't grab an iPad, go do that. Okay. Once you're in our class, there are two ways to get to Delta Math. One of them is going to be more for additional practice, and then I'll show you the other one. So I'll show you both. If you click on the side link, so mine's just going to show my side of it, not your side of it. And okay. If you click on this just so you can get into the class first. So everyone click on that side link. Yes. You should see additional practices for the unit, for this unit. Those are there if you need additional practice / if you do a routine. Anyone not see the additional practice when you clicked on this side?
Over here. See slope, additional slope.
Yeah, so it should be slope, additional practice, and the multi-step and literal. Yes, so you should see those right now. This is for additional practice. That's where you'll see them. You won't see the ones that are due like on Friday, right here. But now I will have seen you populate into the class. So you can go into assignments, the side link on assignments, so hit done at the top. And your assignments will look a little different than mine. Actually, it might be the same way we did, I don't remember. Okay. What's the sensitive? There we go. Okay. So you should see these categories: additional practice. It should be like smaller at the top, and then keep scrolling until you see informative or formative. I want to say the one for today is formative, so find that one. It'll say slope part 1. For assignments. Go into the formative, so keep scrolling for what says formative. And then find the one that says slope part 1, Delta Math slope part 1. When you click in it, so if you're on your computer at home, it will show up right now. But on the iPad, it's going to say launch external tool. You're going to click that. And it will populate for you right there. So you are now doing Delta Math through the assignment in Canvas. Did anyone need help finding that? Just like make sure you did. Anyone else not get it? So you guys can start working on that self-map. If you finish that, answer the discussion on slope. If you finish that, you can keep practicing in your notes. If you need help, please raise your hand. We'll be around. You guys can work together on this.
I'm trying to pause this, but